Hi, welcome back to EduHub Academia and the Education for a Better Future. Today we will discuss lecture number 4 in the course The World of Physics, and it is about electricity. Before we define electricity and get into the field of electricity and all related matters, let's define the source of the electricity, and that is the electric charge. What is electric charge? It is the basic or fundamental property of a particle that will enable it to experience a force when placed in an electric field. It is measured in coulombs. Now, in general, a particle is neutral, and when we say neutral, we mean it has an equal amount of positive and negative charges. When a particle has an excess amount of positive charges, we say it's positively charged. On the contrary, if it has less amount of positive charges than the negative charges, it will become negatively charged particle. When positive charges and negative charges are equal, we say the particle is neutral. Now, lightly charged particles repel, positive repel, negative repel, but unlike particles attract, like positive and negative. Moving from electric charge to electric field, and that is the field that will be created around an electric charge or an electrically charged particle. So when a particle is charged, it has a charge, it carries a certain charge, whether positive or negative, it will create around itself an electric field, imaginary, we don't see it, yet we can feel it. How do we feel it? If we place a test charge, a positive test charge, in the vicinity around this charged particle will be attracted or repelled, meaning there is a force acting on it. And where is this force coming from? It's coming from the electric field. The electric field around a positively charged particle is a vector directed outward, as you can see in the picture, while the electric field lines of a negatively charged particle are directed inward. Now we can define electricity. It is the form of energy resulting from, yes, it is an energy, resulting from the presence and flow of electric charges. When those electric charges start to flow, then we can say there is electricity. Now this charged particle, as we said before, creates its own field, and it could exert a force on other particles. That force we call electric force. It is either repulsion or attraction, like mentioned before. And it is definitely created or caused by the electric field generated by the charged particles. How can we calculate this force between two charged particles? We refer to Coulomb's law. Sometimes we call it Coulomb's force. It's the force between two charged particles, whether they were equally likely charged or unlikely charged, carry equal charges or not equal charges. That's not the issue. The issue is that this force, remember, a force is a vector that has direction and magnitude, which means quantity. Coulomb's law talks about the magnitude, the value of this force between two point charges. And he says that the force is directly proportional to the product of the magnitudes of the charges carried by those particles and inversely proportional to the square of the distance between them, meaning that more charges carried by the particles, the stronger the force is. The distance r squared inversely proportional to f, meaning more distance between the two particles, less force. Now, translated mathematically, Coulomb's law or Coulomb's force is written as F in newtons equal K. K is a constant that we always insert to convert a proportionality into an equation. It's Coulomb's constant, 9 times 10 to the 9. Q1, Q2 are the charges carried by the two particles, and R square is the distance between those two particles. Now we come to fundamental terms in electricity: voltage, current, resistance, and Ohm's law. Starting with the voltage, when you buy a dry cell battery to use in your house for any electric equipment in your house, like a remote control of a TV, you need to replace the batteries. You go and buy the battery, the dry cell battery. It is 1.5 volt, 3 volts, 6 volts, whatever. Car battery has 12 volt, carries 12 volt. Now what is this volt? It is the voltage or the potential difference between the two ends of the battery. It is basically the force or the pressure that push the current out into the circuit to give you light, to give you sound, to give you music, whatever. More voltage, more pressure on the charges to go out, more current you get. So the voltage is the driving force in the battery, in the power supply, that will push the charges out through a conductor to create an electric current. Now what is an electric current? It is the flow of electric charges through a conductor. The rate of flow of electric charges, which means amount of charges flowing per unit time. Now when we talk about electric current, the conventional current, it's the current that flows from positive to negative in a circuit, while the charges go from negative to positive. The third term is the resistance in ohms. Every material, especially the connecting wires that you use in an electric circuit like the one seen here, will show resistance because it's made of a certain material. No matter what a material is, it will show resistance. And I want you to imagine water flowing in a river. If you drop rocks or stones into the river, the water will slow down. You are giving the water more resistance. So think of the water flow as the current. Think of the rocks as the resistance of the current, or against the current. So what is the resistance? It's the measure of how much a material or a device impedes. Impedes meaning slow the flow of electric current. It's measured in ohms, and a higher resistance value means greater opposition to the flow of the current. So we defined voltage, potential difference, we defined electric current, we defined resistance. Now those three can be combined together in something called Ohm's law. What does the law say? It says that the electric current is directly proportional to V of the power supply. More V, more pressure, you get more current. And when the current flows, it will be opposed by resistance, so it is inversely proportional to R, meaning more R, less current. Combining those proportionality into a formula or a law, we say I equals V over R, and simply V equals IR. If you plot V versus I or I versus V for Ohm's law, you get a straight line, meaning it's a linear relationship. So Ohm's law, any material that obeys Ohm's law, we say ohmic. It's ohmic means there is a linear proportionality, meaning the graph is a straight line with a constant slope. If you look at this picture, you can see the V, the voltage of the power supply, negative end, positive end of a power supply. Positive end is a bit higher than the negative simply because this is the higher potential. Negative is at a lower potential. So the conventional current, the positive current, flows from plus into the circuit, meets R, continues to go back to negative end or negative terminal of the power supply. The charges, on the other hand, are moving in the opposite direction to I. Keep this in mind. Our current, our conventional current, is a positive current leaving the positive end of a power supply to return to the negative end. By this, we conclude our lecture 4 in the course The World of Physics. Thank you very much for listening. Please remember to subscribe below.